Hello, it's Monday here in Singapore, and it is only days away to Christmas. 2024 is coming to an end. I hope you had an enriching, exciting, exhilarating, and a wonderful year in 2024. Remember the first video on linear regression model running on Python on Jupyter Notebook? That dataset is a synthetic generated record from Python script, and together we plotted the scatter chart and the trend line, and then we did predictions. Do have a look at that video again. The URL is in the description. Because in today's sharing, I will introduce outliers in the dataset and to show how we can handle outliers using Python function. This is quite important because it is an essential part of data cleaning and organizing data. And in the real world, data analysts and data scientists do a hell lot on data cleaning, organizing the data, and this is part of their work scope. And it can be very daunting. But for today's sharing, it will be just a simple outlier example to get you into the gameplay. Okay, let's get started. Let's go to the screen. Okay, this let me bring out the I thought I had give me a minute. Let's open this. Okay, let's close this one. This is the this is the linear regression model that we did together that I shared with you on the first video. So there's some addition of the code, especially this part. This is the part where whenever there's a new generation of the data set, it will actually export out the CSV into a folder, and this is the folder. I hope you can remember. So the last file that we use is 8.csv. Before today's session, I had actually selected 3, and we modified 2 records to make it an outlier. Okay, let's have a look. So on day 46, yes, it's here. Day 46, I replace the value with 13, a low 13. Okay, and then for on day 97, I replace a high value 355. So this is outside of the trend. So 13 at the low side and 355 on the high side at 90. Is it 97? Yes, 355 on the high side. So let's Let's begin. So we'll be reading out this file. Okay, so let's do this. Let's go to home, new notebook. We're going to write the code. Before we do anything, let's just rename the file outlier example demo. Okay, rename. So this is the code. I'll change to markdown. I'll have the title outliers example demo, DMO. So author date, today is the 23rd December 2024. Okay, so then we'll start the coding. So my usual practice, this is the libraries, and we'll import all the libraries. Import Pandas, as PD, import cbond as SNS, import matplotlib dot py plot as plt. What else? Let me see. Okay, that's I think about all. Okay, let's do a shift enter. Okay, I hope this works. So data frame variable df equals pd dot read csv. So let me copy the link and paste it. Okay, we are here. Just to make sure everything is running proper, can read the file. So df info enter. Okay, so the file can be read. 120 entries, that's correct, 0 to 199. And we only need to be concerned on these two. So it's a int for days and integer for sales. That's fine. In fact, that's good. There's also a date which we will not be using. And just now df dot head just to see the top 5 records. So that's great. And df.tail just to see the bottom 5 records. Shift enter. So 120, that's correct. So 119, 118, 117, 16. So these are the generated sales records. Okay, then we will just the final things. If you want, just the final thing, just to df columns. Okay. Okay, just to make sure that there's no null value. I hope I can remember is na.sum. Yes, so there's no null values. There's no missing values, so that's good. Okay, check for missing values. Okay, we pass. Okay, then we'll continue. Okay, we'll define the x and y. So as usual, my SOP, x is always a cap and y is always a small letter. X equals df x is days, correct. So x is days, y is df sales. That's right. So now we're going to plot the scatter plot with this x and y variable. So plot the scattered charts here now, and plt.figure fixed size equals to, for my screen it is 16:8. For yours, you may have a different value. You can just try it out for yourself that fits into your screen. So plot.scatter x and y, and then color equals blue, my favorite, and label equals sales. Okay, close it, done. And plot plt x label equals to no, so x label as sales, sorry, days We'll do the same for Y label. So Y label will be sales. Then title, plt dot title. We set it sales over days. Looks good. Okay, then we have legend. Then we have plt.greet true. Then plt.show. Okay, we have now completed the code for the scatter chart. Let's run it. Okay, great and nice. So this is the at 46, the 13 value here at day 46. This is at day what's the 97 at 335. So 335 is here and 13 is here. Okay, at 46, day 46. Okay, now we have this chart reflected a correct data. So this is the trend and this is the outlier. These are the outlier two. One is here and one is there. Next we'll assign a temp data frame variable. So df temp equals to df days and then sales. Okay, and print df temp dot to string. Let's run this. So let's double check on day 46. Let's see. Okay, yes, day 46, that's 13. And day 97, so these are all running nicely until 97 here, that's 335. So from 192 it shot up to 335, then it comes back to 188. So these two values are outliers. So outliers can happen and it is usually quite frequent, especially when there's a transition from the manual written data and by converting into digital form, there may be some mistakes that happen that resulted in the wrong interpretation. So, for example, handwriting. One person handwriting is may not be able to. Another person may not able to correctly read and interpret that number. That's also probably one of the cause. Okay, so now what we'll need to do next is, oh sorry, we're going to plot the box plot. Okay, so now let's plot the box plot. Okay, so plt dot figure. For this time around, I'll use fixed size equals to 8 and 6, 8 by 6. Okay, and SNS box plot data equals to df temp. So I'll just need sales and x will be the sales will be the x-axis. Okay, so plt dot title box plot for outliers detection plt.show. Let's hope there's no mistakes. Enter. Okay, this is nice. Okay, as you can see briefly now, here there's a data point here. There's also a data point here. This is defined, or this is recognized as outlier. So we have one over here and one over there. So this is actually 13, and this is at 335. Okay. So before we have some detailed study on this, let me run this code first. So our first df will do describe. Okay, include CLUD, include all .t. Okay, shift enter. So a table has been generated. Let's look at this row. That's the sales. So the sales, it generated the mean value 159.1. There's also the minimum value 13, which is correct at here, which is also the outlier. And we have at 20%, 25%, that's the quantile 1. We have 75%, that is at quantile 3. So 1, 2, 3. Okay, and we have the max value, which is this one. That's also correct at 335, which is also a outlier. Okay, next we're going to compute the Inter Quantile Range. So Inter QENT. So let's do Q1 quantile 1 equals to df temp. To make this easier, let's do sales dot quantile at 25%. So this is quantile 1, this at 25% here, and Q3 at 75, and IQR equals to Q3 minus Q1. Okay. So let's print this. Print quantile 1 so Q1 where do we correct it? Okay, let's do the 3 and Q3. So print Inter Quantile range equals to IQR. Okay, good. Let's add a few more. We need to also have a variable called lower bound equals Q1. Lower bound is the Q1 side. So Q1 minus 1.5 plus times multiplied by IQR, Inter Quantile Range. Okay, and we have also we need to also add the upper bound. So Q3 plus this time plus 1.5 times RQR. So let's print this. Print upper upper bound. So we copy lower bound. Okay, so we run this again. Control and Shift Enter. Okay, so looks good. Okay, now let's study a little bit on this. Now we have identified at 25%, that's the Q1. At 75%, that's the Q3. Okay, so Q1 we compute using the quantile function, and it got the same value. One is it 127? Yes, one at what 25% is 127. At 75% is 187. Correct now. And the Inter Quantile Range is this minus this, which is yes 60. And then we compute the lower bound. The lower bound is 37, is somewhere around this 25. 37 is somewhere around here. Okay, so any points that is below 37, it is considered as a outlier. Any points that is below the lower bound, that's the lower bound outlier. Any points that is higher than the upper bound, that's 277, 277, 275 is somewhere center here. So 277 is somewhere here. Okay. So any value that is above 277, that's the that's also an upper bound. That's also an outlier. Sorry. So there's two here. Uh, and it maps and it corresponds to these two here. Okay, perfect. So we have done this. We have I've also explained this to you. So now let's go and filter out the outliers. So filter filter outliers. Okay, so let's use df clean equals to df temp temp. Okay, so we have df temp sales dot okay, lower than lower bound, and sorry, this is an all df temp dot sales greater than upper bound. Okay, and now we do a print. Okay, let's do this before filtering. Before filtering, number of rows. Okay, that's length df this is temp. Okay, we'll do the same thing, copy, paste, and this is after filtering, number of rows, so this is clean. Okay, well done. Let's hope there's no error. Okay, good. And that's correct, because initially it was 120 records, that's here, so 120 entries, but now it is 118 because it filtered out these two outlier, which is after this filtration. Okay, then we have 118 with df clean. So let's do that. df clean dot info. Okay, so it's a 118. Okay, and now we will plot the scatter plot again, but doing the lazy way. Using the lazy way, just copy this and paste. So plot the scatter chart after filtration. 16.8. Okay, x is df clean dot x is the days, y is df clean dot sales. Okay, let's run this. Okay, good. Okay, sales over days after outliers handling. Okay, run this again. Okay, so the outliers is gone. So we have now the good looking climbing scatter plot. Okay, we'll also now reprint the box plot. Okay, so again, copy and paste. After AFTR, after handling outliers handling. So same thing, box for after. So instead of temp, we change this to clean. So now plot show. Okay, perfect. So we don't have the outlier anymore. So plots after outliers handling. So it is healthy now. Okay. From here onwards, especially with this, we have the df clean. Let's go back to that linear regression page model. Okay, it's actually from here you can continue with the video. So after generating this, you can plot the trend line from here. Then you apply the linear regression model from here. You compute the means MAE, MSE, RMSE, then the R square score. Okay, then after that you do the prediction from 1 to 1 to whatever days that you wish. Then you generate the prediction here. Okay, so we have come to the end of today's video. Let me go back to the main camera. Yes, I hope this is interesting and valuable to you. This is quite important, my field, because writing the code, machine learning is just that few lines of Python codes. But I think the challenging part in this AI or machine learning journey is the data arranging of data, organizing the data, data cleaning, and this is quite a challenge, especially that data is huge and complicated. Okay, if you like, if you value this, if you like this video, please click on the like button and the share, and also please subscribe. It gives me a little encouragement to keep me going in 2025. Okay, thank you and see you the next time.